Alright, I'm trying to create a video on the discussion for today because during my first period we had technical difficulties. There's like some problems with the Promethean and the PowerPoint, and then also I noticed that there's several of you that were absent today. Okay, so that's why I'm trying to create this video. Okay. So now, for today, what we discuss today is about the angle launch projectile. And the angle launch projectile, it is launched at a certain angle, and we started with this animation here. And if you're going to look at the animation here, you will see here the horizontal and the vertical components of the velocities. Okay, velocities. Velocity is a vector, so it is represented by arrows here. Projectile is a two-dimensional motion, so we know that it has horizontal and vertical components. Okay, so let us look at first at the horizontal component, which is going this direction. Okay, look at the arrows. What is going on? We can see here that the direction is not changing, and also the magnitude is not changing. We can actually see it here that when it started at 60, the Vx, which is the horizontal velocity, never changed. Okay, so it's 60 meters per second, so there is no change in velocity. But if we're going to look at the y component, the one that is going up and down, as it's going up, we can see that it is going up, and then here it is going down, so it's changing direction. Aside from that one, we can see that the magnitude is changing. See, it's getting smaller, it's getting bigger. Okay, so as it's going up, it is decreasing in the velocity, and going down, it is increasing in velocity. You can see it here actually. And if you're going to notice, it is increasing. It is decreasing by 10 meters per second. It's also increasing by 10 meters per second. To be more specific, it is increasing and decreasing by 9.8 meters per second because the acceleration that we have in the y component is 9.8 meters per second squared. Okay, so if you're going to look at the handout that is given to you right here, if you're going to answer it here, if this is our projectile, oops. If this is our projectile here, we know that this shape, the trajectory, is a parabolic shape. So it is a parabola. And based on the animation that we have earlier, we know that the velocity that is constant all the way is the Vx, or the horizontal velocity. Okay? And then now, we in the vertical velocity, we know that the only force acting on this projectile is the gravity. So it means the only acceleration, the acceleration that we have in the y component is g, which is 9.8 meters per second squared, and it's always pointing downward. Okay, if it can be positive or negative depending on what you set as what direction you set as positive or negative, but the g is always pointing downward. Okay, so if we're going to look at this one, the vertical velocity is blank at the launch. We know that based on the animation, if we recall, this one is when it's going up, we know that the speed is decreasing, so it means at the launch it has the highest velocity, and then during the climb it is decreasing in velocity. The Vy is decreasing by 9.8 meters per second every second. Okay, and then one thing that we should notice here also, that as it's going up and reach the highest position, the Vy is 0. This one is always true for horizontally for the angle launch projectile. And then we should know that the Vx is still constant. It will not be 0. Okay, it's still constant because horizontal velocity is constant all the way. Okay, next, during the fall, when it's falling down here, the vertical velocity is increasing by 9.8 meters per second every second, and then Vy is highest just before the impact. Okay, so because we know that it is increasing as it's going down. Okay, and actually, if you're going to, let's say for example, at this point, the Vy here is 20 meters per second. If you go to the other side of the projectile, which is the same level, same height, which is here, the Vy here will also be 20 meters per second. Okay, the only difference is this one is going up, this one is going down. So if we set this as positive, this should be negative 20 meters per second. Okay, same thing if we have here the, let's say for example, after 1 second, it became 10 meters per second. If we go to the other side of the projectile with the same level, the Vy will also be 10 meters per second. Okay, again, this will be negative if we set this one as positive. Okay, so based from that one, we can summarize what we discussed. In the vertical direction, gravity is pulling the ball downward, so it slows down when it is moving upward and speeds up when the ball is moving downward. Okay, next thing, and this is just the answer to that one also. Okay, here I separated the horizontal component and the vertical components of the acceleration, velocity, and distance. Acceleration, velocity, and distance. Okay, if we're going to recall, in the horizontal velocity, the Vx is constant, right? It doesn't change. It's not changing direction. So if you do have a constant velocity and not changing the direction, it means there's no acceleration. If there's no acceleration, it means the acceleration in the x direction is 0 meters per second squared. Okay, for the vertical component, the acceleration that we have is 9.8 meters per second squared. If it's positive or negative, it depends on what direction you're taking. If you take positive as upward, it means this one should be negative, right? Now, for the Vx or the Vox and the Voy, the initial velocity components, x and y components, we need to use our trigonometry. So if you're going, let's say for example, this one. Initially, you're given the initial velocity Vo. We need to find the Vox. Say this one, Vox. Assuming that is straight. This is Vox. And then we need to find the Voy. Just this one. We need to use the trigonometry, the basic trigonometry, the sine, cosine, and tangent. If we're going to look at this one, we know that this is adjacent and we're given the hypotenuse. So here, what we're going to use is the cosine, because this is adjacent and this is hypotenuse. So cosine of theta equals to Vox divided by Vo. So if you want to calculate the Vox, you need to multiply Vo, cosine of theta. And same as with the Voy right here, but instead of cosine, we're going to use sine because we know this is opposite and this is hypotenuse. So sine is opposite, sine theta is equivalent to opposite, which is Voy. And the hypotenuse is Vo. So Voy would be Vo sine of theta. So if you're going to write it down here, the Voy will be Vo sine of theta, and the Vox will be Vo cosine of theta. See the pattern? They are the same, only difference for x it's cosine, for y it is sine. Okay, next. The distances. The horizontal distance, which is delta x. You can use the equation that you used before last week, Vx delta x over delta t. And we're arranging for delta x, it should be Vx times delta t. For the vertical component of the distances, we cannot actually use the one that, well, we cannot always use the one that we used last week. Okay, it depends, as well as if you want to calculate the final velocity in y. Okay, this one you can use the kinematic equations. And which kinematic equations, I cannot tell you specifically which one. It depends on what is asked and depends on what is the given. Okay. All right. Now, these two questions here, because sometimes they're asking questions like this: how do we get the total velocity? So here, let us switch it. Instead of us given the initial velocity, what if we're given VOY and VOX? How do we calculate the total velocity VO? Okay, looking at this one, if we're given this and this, how do we calculate this? Remember that we can use the Pythagorean theorem, which is c squared equals to a squared plus b squared. So in terms of the symbols that we have here, the VO, which is our c, will be equivalent to square root of VOY squared plus VOX squared. AX plus b, a squared plus b squared, square root of that one, you'll get the total velocity. Okay, next, launching angle. How are we going to get the launching angle? If we're given VOY and VOX, look at this one. Given this one, given this, how do we calculate the angle? You can use the tangent. The tangent ratio. Okay, why? Because it's adjacent and this is opposite, so we can use the tangent. But since we are looking for the angle, we need to get the inverse tangent of the opposite divided by hypotenuse, and our opposite is VOY divided by VOX. Okay. Alright, so now before we go to the actual calculations, I would just like to mention that there is these two special equations. These two special equations, it's not given on the formula chart, and I will not be giving it to you on the test, but sometimes it's convenient to know this one if you're running out of time. Okay, one thing that I would just like to emphasize here is that here students are always getting confused with this one. This means actually that you are squaring the sine of the theta, so you can just write it that way. Okay, and then here you need to multiply the theta, which is the angle, by 2 before you get the sine. Okay, and then take note here that the VO right here, VO is the total initial velocity. Okay, I'll use this one later on to see how this is easier if you know it in some situations. Okay, looking at this one. First one, a football is kicked at 60 degrees above the horizontal at 25 meters per second. First thing, sketch. Okay, do you need to sketch all the time? It is helpful. Okay, so they said the football is kicked 60 degrees above the horizontal, so this is above the horizontal, and then you do have a 25 meters per second. And what is this 25 meters per second? It is the velocity. What kind of velocity? It is the total initial velocity. It is not the horizontal velocity. It's just saying here that 60 above the horizontal. It's not saying that this is the horizontal velocity. This is saying that it's launched at this speed. Okay, so that is your VO. And then you know that to go that way, if you want to calculate letter A is what is the horizontal component of the initial velocity. So we have the initial velocity horizontal. What is this? Okay, we need to calculate this one, and based on what we discussed earlier, VOX is VO cosine of theta. I just need to plug in the values. VO is 25, cosine of 60. If we plug in this one in the calculator, we're gonna get 12.5 meters per second. Okay. Oh, by the way, make sure you are in degree mode. If you are not in degree mode, you're gonna be getting a different answer. Okay, next. B. What is the vertical component of the initial velocity? So initial velocity, vertical. What is this? This is what we need to calculate. Okay. So same as letter A, but instead of cosine, we're using the sine. And plug in the values. 25 sine of 60. This one should be equivalent to 21.65 meters per second. Okay. Next. Letter C. What is the maximum height does the football reach? So we need the height. If we need the height, maximum height is on this position, right? Which is your delta y. What is our delta y? Okay. Most of the time the student will think that this is the equation that we're going to use. We cannot use this. Why we cannot use this? Because we don't have the time. So we cannot use this one. So the other kinematic equation, the only other kinematic equations that has delta y would be the third one is vy squared plus 2a delta y. If you notice, if you look at your yellow formula chart, I changed all the y's to all the x to y's. Okay, so here we can simplify this equation. Okay, how can we simplify it? We're looking at the maximum height. We know that at this point the vy is 0, right? So we can have this one as 0. So if we cancel this one, we rearrange the equation. We have this 0. We have this as VOY squared. And then we can have this one as since if we set this one as positive, the acceleration, which is g that we have, is going downward. We can have a negative 2g delta y because it's moving downward because of this g. That's why it's negative. And if you arrange the equation, just do your rearrangement. Okay, if you need help with arrangement, just see me after school. It'll be like this. Okay, plugging in the values. Don't forget to square. 2 times 9.8. Okay, common mistake. Make sure you multiply these two first before you divide, okay? Or put a parenthesis on this. So delta y is, if we plug this in the calculator, delta y will be 23.91. Alrighty, next. Letter D. How long is the football in the air? Okay, so how long will be the time? Okay, there are two equations that we can use. We can use this equation to solve for t. If we have delta y, VOY t plus 1/2 gt squared. We can set VOY as 0 if we set that this is our starting point and this will be our final point. You can do that one, and this will be 0, and it will be similar to the equations that we used last week in the horizontally launched projectile, which is this one. You can use this equation, or you can use the first kinematic equation, which is the VOY plus GT. Okay, And like here, we know that Vy would be 0 if this is 0, and then G is pointing downward, this is negative. Then we're going to have, if you arrange the equation, T will be equivalent to Voy divided by G. Okay, whatever, either equation will give you the same answer. Okay, but I will just put it here, in this one. Voy will be 21.65 divided by 9.8. You will get 2.21 seconds. Okay, but be careful. This 2.21 seconds is only for going up. The question is how long is the football in the air? So it means you need to double it. So your total T would be double of this one, which is 4.42 seconds. So this is our final answer for that. Okay. Letter E. How far away does the football land? So how far is the distance, and where the football land, that will be delta x. And we can just use the equation that is on the table that we have earlier. Plug in the values. The Vx will be the same as Vox because we say that the Vx never change. So it will be 12.5 divided by the time, which is 4.42. That's what we're gonna use. So our delta x will be 55.25 meters. Okay, now, so this is how we're gonna answer this one. Okay, I would just like to point out here that sometimes, especially in the multiple choice, if they ask you for delta x, you need to go through these steps in order for you to get delta x. But if you know the special equation right here, you can just easily calculate it. Okay, well, of course, it depends on the givens that you have. But usually, they're giving you the angle and they're giving you the initial velocity. Okay, so let us try it. If, let's say, for example, on this given, we use this special equation. The VO is 25. Oh, no, sorry. Oh, yeah, that's 25. 25 squared. Sine of 2 times 60 divided by 9.8. What you're gonna get here will be 55.23 meters, which is very close to this one. And actually, if you didn't round off anything right here, you're gonna be getting 55.23 also. Okay, same as with this one, the delta y. If you know the special equation, as here, the delta y max, so we have 25 squared sine of 60 squared divided by 2 times g, which is 9.8. Again, do not forget to multiply the 2 first or put in the parentheses. Delta y is very close to this answer, which is 23.91 meters. So this answer and this answer will be the same. Okay, so again, these special equations, you may use it on the test, although I will not be giving it during the test. It's up to you to memorize it or to use it. Okay. Alright, so these are the answers to the rest of the, well, not really the rest, the other problems. Number 2 is exactly similar to number 1. The only difference is we change the angle. And I give the answer to number 6. I didn't give the answers through 3, 4, 5, 6, 3, 4, 5 because if I give the answer, that's the answer already. I would like you to think about it first. Okay, I'll be showing you the answers later on. Right. So if you do have any question, you can always attend the tutorials. And that's it. This is included on your test on Friday. Okay, good luck on your test.